x and y intercepts of the graph of polynomial function. For the x-intercept, it is defined as the point where the graph crosses the x-axis or the horizontal axis, meaning y value is 0 at that point. While for the y-intercept, it is defined as the point where the graph crosses the y-axis or the vertical axis, meaning the value of x or the x value is 0 at that point. To get the intercepts of the graph of the given polynomial function, such as y equals x cubed minus 4x squared plus x plus 6, particularly finding the x-intercept or x-intercepts, we make use of the factored form. So meaning, we need to factor the polynomial part of this polynomial function. Now, to carry out the process of factoring the polynomial part of the equation, we use the synthetic division. So here we are going to consider all the coefficients from this expression, including the constant term. And these are 1, negative 4, plus 1 taken from x. Again, 1 is taken from the coefficient of this term. Negative 4 is obviously taken from this term. Then positive 1 from x, and the constant term plus 6 or positive 6. And for the root to be used, we consider one of the factors of the constant term 6. So we will begin with the smallest or the first factor of that constant term, say negative 1. Then we carry out at this point the synthetic division. So we bring down 1 multiplied by negative 1, so that is negative 4 added to negative 4. We have negative 5. Negative 5 times negative 1, that will give you positive 5 to be added to 1. We have positive 6. Positive 6 times negative 1, we have negative 6 placed under positive 6. And then we add these two, it will result to 0 remainder. So it means we achieved a 0 remainder, meaning we found the right root for this polynomial, or root or 0 of this polynomial function. Actually, at this point, we have just obtained one of the x-intercepts. Now, since the degree is 3, meaning there are 2 more x-intercepts. So, actually, there is no need for us to factor this polynomial expression. But then we need to express the factored form anyway. So meaning, if we have a root of negative 1, it follows that the first factor we obtained is x plus 1. Okay. Next, to go on with the synthetic division, this time we consider this row of 3 numbers. So we have 1, negative 5 plus 6, and we consider another root, which is also a factor of 6. Since we have already tried negative 1, this time we try the next one, positive 2 or 2. Then we do the same process of synthetic division, this time with these 3 numbers. So bring down 1 times 2, that is plus 2, to be added to negative 5, that is negative 3. Negative 3 times 2, we have negative 6. And again, we got a 0 remainder, meaning 2 is the second 0 or root of this equation, or 0 rather. Yeah. And from here, from this value, the second factor is actually x minus 2. And the third one is obviously found here. So if this is 0, remainder, this is your constant term, and this one right here is the coefficient of the term whose degree is 1. So, meaning we can express this as a linear factor of x minus 3. Okay? So, it means we have just obtained the 3 factors, and let us put these 3 factors together. That is the equivalent of and they are the equivalent of this polynomial expression. So, therefore, the given polynomial part is equivalent to quantity x plus 1 times quantity x minus 2 times quantity x minus 3. Okay, so that is your y. Then, to get the x-intercept, basically, y is set to 0. So y here will now be replaced by 0. And then each factor is to be equated to 0. X plus 1 equals 0, or x minus 2 equals 0, or x minus 3 equals 0. So we have 3 resulting linear equations in one variable. For each resulting equation, we can now easily find the value of x. For the first equation, we have x is equal to negative 1. For the second equation, the value of x is 2. And for the third equation, the value of x is 3. So you will notice that these are the roots in the synthetic division that we have used from the previous slide. So the x-intercepts are again negative 1, 2, and 3, which means the graph of this given polynomial function will pass through the following points. And these are negative 1, 0, 2, 0, and 3, 0. Okay, now for the y-intercept, from the given polynomial function, this time we're going to set x to 0 and solve for y. So this is again the given function. So all those x's are now are to be replaced by 0, and then simplify the resulting polynomial part. And your y is equal to 6, which is your y-intercept. Therefore, the graph along the y-axis will cross or will pass through the point with coordinates 0 and 6. For our next example, how about finding the x and y intercepts of this next polynomial function? We have y equals x to the 4th plus 6x cubed minus x squared minus 6x. So for our solution, we find first the x-intercepts, and by doing so, again, we use the factored form. And for the factored form, we apply the synthetic division. But first, before we proceed to the synthetic division, we must take note of this polynomial part. There is no constant term, but if you observe each of these 4 terms, there is a common factor of x. So we factor out x here from each of these terms. So the polynomial part will become x multiplied by the quantity, the expression that is left after we factor out x is x cubed, which is the result of dividing x to the 4th by x, plus 6x cubed divided by x, that is 6x squared minus x squared divided by x, that is x, minus 6x divided by x is equal to 6. So the one that is to be factored here is the expression inside the parentheses. Okay? So taking those coefficients from that polynomial inside the parentheses, by synthetic division, we have 1 taken from x cubed plus 6 taken from 6x squared minus 1 taken from negative x or minus x, and the constant term negative 6. Then we use the root, which is the smallest factor of negative 6, which is negative 1. Then we do the process of synthetic division, so we bring down 1. 1 times negative 1 is negative 1. 6 plus negative 1 is positive 5. Positive 5 times negative 1 is negative 5. Negative 1 plus negative 5 is negative 6. Negative 6 times negative 1 is plus 6. Then bring down 0. So therefore, we have just obtained one of the zeros, or the x-intercepts, or x-intercept, which is negative 1. Next. Okay, so that is x plus 1 as our first factor of this polynomial inside the parentheses. Then we need 2 more factors since the degree is 3. So there are 3 factors of this polynomial. Okay. So we take these 3 numbers, 1, 5, and negative 6, and we divide it by another root, which is another factor of this constant term. Say, positive 1 this time. Then we do the synthetic division. So bring down 1. 1 times 1 is 1 or plus 1 added to positive 5, that is plus 6. Then positive 6 times 1 is positive 6. And we add these two. The result is 0, which is the remainder. Therefore, we obtain the second value, or the 0. And from this value, the second factor would be what? X minus 1. And the third factor can now be easily identified from this row of 2 numbers. So if this is the constant term, this term has a degree of 1. Therefore, the expression is x plus 6, which is our third factor of this polynomial inside the parentheses. So the given polynomial function can now be expressed in factored form as your y. So that is y equals x quantity x plus 6 times quantity x plus 1 times quantity x minus 1. Then we set y to 0 since we are looking for the x-intercept. There. And then each factor is now equated to 0. So for the first linear equation, we have x equals 0 taken from this factor. And for the second factor, that is x plus 6 equated to 0. For the third factor, x plus 1 equated to 0 also. And the fourth factor is also equal to 0. So we have 4 resulting linear equations in one variable of x. So each equation can now easily be solved. For the first one, it is already determined as 0. Then for the second equation, x is equal to negative 6. For this next equation, x equals negative 1. And for the final equation, x minus 1 equals 0, x equals 1. So the x-intercepts are these 4 values, which means the graph of the given polynomial function will cross the x-axis at 4 points. And these are 0, 0, negative 6, 0, negative 1, 0, and 1, 0. Okay. Now for the y-intercept, this time this time x is set to 0 and solve for y. Basically, all terms with x variable, x is replaced by 0. So then simplifying this resulting expression, therefore y is equal to 0, which is your y-intercept. So the graph will cross the y-axis at point 0, 0, which is the point of origin.